Welcome to our video on perfect square trinomials and how to factor them. What is a perfect square? Well, here's a perfect square, and that looks like a 4 by 4 square. So 4 squared equals 16. You can see 16 individual squares in there. So 4 squared is 4 times 4. That is called a perfect square. 16 is a perfect square because it is composed of two numbers multiplied by each other, the same number multiplied by itself. Let's take some notes, get your notebook ready, we'll add some examples. What is a perfect square? Now we're going to talk about it algebraically. Just like 4 squared was a perfect square, this algebraic expression x plus 3 squared is also a perfect square. This expands to x plus 3 times x plus 3. Those are the two factors. If you multiply that through, you'll have x squared plus 3x plus 3x plus 9. And you can combine the 3x's to get x squared plus 6x plus 9. This is called a perfect square trinomial because it began with this perfect square right here. Just like we had 4 squared and then 4 squared became 4 times 4, this thing became x plus 3 times x plus 3. And the result is a perfect square, just like 16 was the result of 4 squared and 16 was a perfect square. This is now a perfect square. It's called a perfect square trinomial because this is a polynomial. Any string of terms like this in algebra is called a polynomial, and trinomial means it's a polynomial with 3 terms, 1, 2, and 3 terms. Now, something interesting about this perfect square trinomial is that we can rewrite it like this. The first term is x squared, which is x squared. The last term is 9, which is actually 3 squared. So at the beginning we have something squared, and at the end we have something squared. And in the middle we have 2 times those last pieces. So here's 3x, and in the middle that 6x is actually 2 times that 3 in the x. This pattern will always be true for perfect square trinomials. Let's look at some more examples. So when you're factoring perfect square trinomials, they'll always take this form, just like we saw in the last one. There'll be something squared at the beginning, something squared at the end, and in the middle, 2 times that thing and that thing. Or it can also have a negative form. It can be a negative here, and it looks the same. Something squared in the beginning, something squared at the end, and in the middle, 2 times the first thing and the last thing. And that one factors into this, a plus b squared, and this one with the minus sign factors into this, a minus b squared. Let's look at some examples with numbers in them. So looking at the first kind of type with all plus signs, here's a sample. Look at this trinomial. In the beginning we have something squared. It's x squared. At the end we have something squared as well. It's 5 squared. And in the middle we have 2 times x and 5. So we can rewrite it like this. Here's that first part squared. Here's the last thing squared, 5 squared. And in the middle, 2 times 5x. So that thing will always factor like this. So you don't have to write this. If you can jump from the first one right to the end, that's okay. So that will always factor like this. It will always be the x plus 5 squared. Now let's look at an example with a negative case. Here's a sample. We have x squared minus 14x plus 49. Again, you look at it and you see it's a trinomial. And you look at the beginning, yes, it is something squared. At the end, yes, it is something squared. It's 7 squared. And in the middle, is it 2 times the last number and the x? Yeah, this would be 2 times 7x makes 14x. So I'll rewrite that to show that in the beginning we have something squared, which is x squared. At the end we have something squared, which is actually negative 7 squared. And in the middle we have 2 times negative 7 and x, so 2 times negative 7x. Since that trinomial takes this form, we know it's a perfect square, and it will factor into this. X minus 7 squared. So it's the first thing minus the last thing because of the minus sign squared. If you were to multiply this out, you'd get right back to there. So perfect squares, it's just a matter of recognizing that you have squared, squared, and in the middle 2 times the two numbers. Alright, you're ready to try a couple. Take a look at those two and see if you can factor those. First of all, make sure they're perfect square trinomials, and then try to factor. Okay, check your work. In the first one, it definitely follows the pattern. 4x squared is something squared. It is 2x squared. And at the end we have a 1. A 1 is 1 squared. And in the middle we have 2 times that first thing and the last thing. So it's 2 times 2x and 1. So since that is a perfect square trinomial, it factors into this, which is the square root of that, 2x, plus the square root of that, which is 1. 2x plus 1 squared. In this example, it was necessary to find a GCF first. So never forget to do that. When you look at any kind of polynomial and you need to factor it, always look for a common factor first. There's an 8, a 24, and an 18. 2 is a number that goes into all three, so 2 was factored out. Once the 2 is factored out, we have a new trinomial here, 4x squared minus 12x plus 9. Now that one, look at it closely. At the beginning, we have something squared. 4x squared is actually 2x squared. And at the end, we have a 9, which is actually 3 squared. Now we check the middle term. Is this term 2 times 2x times 3? Let's see, 2x and 3. Yes it is. That makes negative 12x. So that means we have a perfect square trinomial. And if this is a perfect square trinomial, it factors into this 2x minus 3 squared. Because this is 2x, and this one is a 3, and we have a minus sign, so 2x minus 3 squared. Make sure you have written those examples and consider them closely before you try the practice assignment. So find the practice assignment on the website and do your best. All the questions in the practice assignment will be perfect square trinomials, just a matter of figuring out what the squares are and how to factor them. You can do it.